Hey guys, welcome to another episode on my channel. So today we are going to talk about this VEML6040 color and light sensor. This is already prepared PCB, so you don't have to do any soldering. The only thing that you have to do is to connect this sensor to your ESP32 or Arduino microcontroller using I2C communication. And in here you have 4 pins. First one is for 3.3 volts, second one is for ground, and you have 2 communication pins, SCL and SDA. On the front side you have this flashlight you can see in top right corner. And in that way you know that this is front side. So I'm just going to plug this sensor to my breadboard. Like this. I'm going to connect 4 wires on the back side. All right. And now on ESP32 microcontroller SDA it's pin 21. So I'm going to see which one is SDA. It's the 4th one, and I'm going to connect it to pin 21 on my microcontroller. Next one, the blue wire, it's SCL. So that is pin 22, and we have 2 more. One is for 3.3 volts, and we have one for the ground. So everything is ready. Now we are going to deal with the coding. Now, first thing that you have to do, go to your platform IO home, select libraries and check for VEML6040. This is the very first one. Yeah, it is this one. Add this to your project, select your project name. All right. Now you don't need platform IO home anymore. Platform IO INI it's also unnecessary. We are going to deal only with main CPP from now on. Okay, first we have to include wire library. Next we need to include VEML6040. Now we need to So I'm going to call it color sensor, VEML6040 color sensor. This is fine. Now I'm going to initialize my serial monitor with baud rate of 9600, and you have to know that this baud rate is necessary in case of VEML6040 sensor. So next thing, I'm going to initialize my wire library. All right, and now we are going to initialize this color sensor. So if not, color sensor dot begin, we are going to print something like sensor problem. All right, we are going to make delay of 1 second, and we are going to return. All right. Now there is one housekeeping stuff. We have to set configuration for this sensor. So color sensor dot set configuration. All right. Now first thing, it's VEML6040. Okay, I have 1 letter more than necessary. IT 320 ms plus VEML6040 underscore AF. You have 2 modes, auto and force. We are going to use auto. And one more thing, VEML6040 underscore SF D, enable. All right. And now we can actually read from this sensor. Okay, I'm going to remove these unnecessary empty spaces. And in here, I'm going to, first, I'm going to take numbers. Why? I'm going to create unsigned integer 8 bits. R, and I'm going to make some calculation. Don't worry, I'm going to explain everything in details. 225 times. Now I want to cast this to float, that's first part. And what I'm going to calculate? I'm going to cast to float also color sensor get red, so we are getting a red color first, and I want to divide that by 65,535. So what this number actually is, this is maximal value for unsigned integer 16 bits, and that is actual type of variable that we are going to get with get a red function. That means that number that we are going to get as the result is going to be in between 0 and 65,535, and we don't want that. What I want is number in between 0 and 225. And in this calculation you could actually use 100 if you like that better. I'm going to go with 225. Alright, I need semicolon at the end, and I want to copy this line, let's say 4 times. All right, so first what we want to get is this red color. Now we are going to deal with green color, then with blue color, and W for white. Okay, don't worry, everything is going to be explained. No, I need red in here, get red. Now get green. Third, it's get blue, and get white. So RGB are regular 3 components from RGB color system. This W that stands for white, it's actually a strength of light that we are going to get from readings from this sensor. And there are actually 2 more components. Let me show you. Now I'm going to use a regular integer, it's fine. CCT. With CCT we are going to read temperature of color, and we are going to use, of course, color sensor get CCT in order to get that number. Now I'm going to use float in this case for ambient light. Okay, and we are going to get it with color sensor get ambient light. Okay, and now we are going to print all of this to our serial monitor. So I'm going to use serial print F, and how we are going to do that, let's say I'm going to use red column %D, then tab, now green column space %D, another tab, blue column %D, one more tab, of course white, another tab, then CCT column, D in here too, and finally ambient like this, but in here we have to provide not D but F for float, and I'm going to have new line. Okay, so first we have to provide R, G, B, W, CCT, and AL. Okay, and I'm going to make delay of half a second. It's totally fine, I believe. I'm going to build this code and upload it. Alright, so everything is up and running. Now let's check our result. Alright, you should be able to see my sensor and microcontroller on the screen now, and I'm going going to turn on my serial monitor in order to see what we are going to get. Okay, we have some result. All right, now I'm going to bring something red to my sensor and let's see what we are going to get. All right, we have different numbers now. I'm going to pull this screwdriver away, more away, now much closer. All right, let's see what is going to happen when I bring my finger to it. You see we have different result now. And what if I cover this sensor with my hand? We also have different result. All right. So guys, that's all for this episode. I hope that you learned something new, something interesting. So please like, subscribe, and see ya.